This is SpaceTime Series 21, Episode 38. Coming up on SpaceTime, the new study is showing galaxies are getting bigger and puffier as they age, NASA's plans to fly a helicopter on Mars, and the Earth's orbit being changed by Jupiter and Venus. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have found that just like some people, galaxies can grow bigger and puffier as they age. The findings, reported in the journal Nature Astronomy, represent the first time astronomers have shown that the shape of a galaxy can be directly related to its age. Because there's no obvious link between a galaxy's age and its shape, the discovery of a connection was surprising and could point to a deeper underlying relationship which is not yet fully understood. As a galaxy ages, changes take place. Molecular gas and dust clouds collapse, forming new stars, which eventually migrate through the galaxy. Meanwhile, as some stars are born, others explode in supernovae, sending shock waves through neighbouring star systems and gas clouds, in the process moving and rearranging huge regions of interstellar space and triggering new star birth. Black holes are also forming in some of these supernovae, generating powerful jets as they consume surrounding material. And these jets can also blow stars and gas away, triggering even more star birth, or totally emptying parts of galaxies of material for new stars. Galaxies are also constantly interacting gravitationally with each other, changing shape, swapping stars, and merging or cannibalizing each other. All these events are constantly changing galaxies and the way stars are moving in them. To determine if there are any common galactic themes to a galaxy's shape, the authors measured the movement of stars in galaxies using an instrument called SAMI. SAMI is meant to stand for Sydney AAO Multiple Object Integral Field Spectrograph. It uses plate-plugged optical fibres that feed the AAO Mega spectrograph to collect data from 13 separate galaxies simultaneously. It was originally developed to undertake a major galactic survey of over 4,400 galaxies. The authors used the SAMI data on 843 galaxies to examine the shape and age of a wide range of galaxies of all different types, shapes, masses and ages. One of the study's authors, Professor Matthew Collis from the Australian National University, says stars in young galaxies usually move in an orderly way around the galactic disk, much like cars going around a racetrack. Collis says all galaxies look a little bit like squashed spheres, but as they become older, they get more puffier, with stars going around in all different directions. Astronomers measure a galaxy's age by looking at its colour as young blue stars grow old and turn red. When the authors plotted how ordered the galaxies appeared against how squashed they looked, the relationship with age really leapt out. They found that galaxies with the same squashed spherical shape have stars which are the same age as well. Scientists had known for a long time that shape and age were linked in some very extreme galaxies, that is, very flat ones and very round ones. But this is the first time they're able to show how the shape of any galaxy can be directly related to its age, not just the extreme ones. Collis says this data from SAMI has confirmed something that's been suspected for quite a while.
Turns out that, like humans, galaxies suffer middle-age spread. So what we've been doing is we've been using the SAMI instrument on the Anglo-Australian telescope to map out both the ages and the shapes of galaxies. And what we've found is that, in fact, there's quite a simple relationship between the two. Galaxies get rounder as they get older. And what that means in detail is that the stars in a galaxy, on average, are older in galaxies that have a rounder, less elliptical shape. And this seems to be something that's actually an evolutionary thing for galaxies. And it's news because although we've suspected this for a while, until we had the SAMI instrument, we weren't actually able to map out the galaxy's intrinsic shapes. And with that new information, we can now make this clear correlation between the two things, age and shape.
What's the difference between round and elliptical? I thought they were the same sort of thing when we talked about galaxies.
Round is a soccer ball, elliptical is a rugby ball.
Okay.
So what we're measuring is galaxies have both disks, which are flat, and bulges, which are generally fairly round, spherical-ish. And in between those, you can have bulges which are a bit more elliptical and disks which are a bit puffier. But in fact, mostly it's the combination of the disk and the bulge together which gives a galaxy its overall shape. And we've been looking at that overall shape. And in order to do that, you've actually got to look at how the stars are moving in the galaxy. Because when you look at a galaxy face on, if you look at a disk face on, you can't tell if you've got a flat disk which you're seeing from the top or the bottom, or whether it's a genuinely spherical galaxy. And the only way of telling that is to look at how the stars are moving inside the galaxy. And that's what we've been able to do. And that gives us the intrinsic shape, whether we're looking at a disk or a football or a soccer ball. To give an example, the Milky Way is a pretty average sort of galaxy. It's a middle-aged galaxy. It's about 10 billion years old, so that's younger than the oldest galaxies, which formed 13 billion years ago, but it's considerably older than the very youngest galaxies, which are still forming most of their stars even today. So it's middle-aged. It's got both a disk and a bulge. The bulge is large, but it's dominated by the disk. Now, if you saw our galaxy edge on, you could see that it had both a disk and a bulge in the middle. If you saw it face on, in other words, from the top or the bottom, you wouldn't be able to tell whether it was a big round galaxy or a combination of a disk and a bulge. But we can tell that if we look at how the stars move, because stars in a disk move in nice, smooth, circular orbit, whereas stars in a bulge move on random orbit. The bulge is supported by the pressure of the stars, like a gas, whereas the disk is supported by centrifugal force, like the skirt of a ice skater spinning on the spot.
What are we extrapolating with that? As galaxies age, the bulges get larger and the spirals get smaller?
Yes, that's right. It seems as if there is a general tendency that varies a lot from galaxy to galaxy. So we're talking averages of the whole population here. But it seems as if in general, as galaxies get older, they tend to be more rounded. They have less disk and more bulge. Now, it could be two things, right? It could be an evolutionary effect where the disk is gradually being turned into bulge by what we call secular effects, which is just the overall evolution of how stars orbit over time. But it could also be that galaxies that formed longer ago tended to form more rapidly and so form more of a bulge and less of a disk. So we don't know whether there's something that is printed on galaxies when they form or whether it's evolutionary, but it's got to be at least one of those two things.
And we're also seeing the outer edges of galaxies getting larger as well, aren't we, as gas is converted into stars in the disks?
That's right. Galaxies grow inside out. So the oldest things in all galaxies are in the middle, and the youngest things tend to be at the edge. Now, there are counterexamples to that. Sometimes a galaxy swallows another galaxy, and gas actually reaches right into the center of the galaxy, and you get a burst of central star formation. But nonetheless, as a general rule, galaxies grow from the inside out, with the oldest things in the middle and the youngest things on the edge. So as they grow, you've got this blue periphery, usually in a disk, and an old red center, usually in a bulge. So
that's what we're looking at when we talk about galaxy evolution. But all that is, as you just mentioned, also affected by the merger of galaxies. Galaxies get big by merging and cannibalizing each other. That must put an extra sprinkle of confusion on top of what you're seeing.
That's right. So what I've been talking about is the gradual change, the steady evolution of a galaxy if it's left alone. But of course, if you start banging galaxies together in collisions and mergers, bad things can happen. So for example, in just a few billion years from now, the Milky Way and Andromeda will collide with each other and probably turn into a single giant elliptical galaxy. Now, that galaxy will probably not have a disk because all of the gas will have either been consumed in a burst of star formation or stripped out of the galaxies and heated up to a point where it can't keep forming stars. And all you'll be left with are the existing stars. And because the two galaxies have merged in a practical way, those stars will mostly be on random orbits. And so you'll end up with one of these almost spherical or at least elliptical galaxies which don't have a disk. So you can short-circuit the whole gradual evolutionary process by banging galaxies together in that way.
When we look at our galaxy, it's not quite just a spiral. It's what we call a barred spiral galaxy because it has an elongated bar in the middle where the central bulge is located in that area. Are there any specific hypotheses out there to try and explain why some galaxies have bars?
What seems to be happening is that dynamical effects which produce the spiral arms in the center tend to produce bars. And in fact, the bar mechanism is one of the ways we believe that flat disks are actually spun up and converted into fat pressure-supported bulges. So a bar is a way in which the dynamics of a disk can be converted into the dynamics of a bulb. And in doing so, the gas is either converted into stars or, in fact, heated up and thrown out of the galaxy. And that's one of the reasons why stars are a way of creating these old bulges with no new star formation.
That tells us something about its age then as well.
It can, although bars can come and go in galaxies. They seem to be sometimes a transient phenomenon, either sparked by the spiral density waves themselves or by a minor merger or a close encounter with another galaxy. So they can come and go, and a galaxy might have a bar and then not have a bar and have a bar again. So it's a bit hard to say that they're a definite age in evolution. They're more like a phenomenon that happens which helps evolution along its way.
That's Professor Matthew Collis from the Australian National University. Meanwhile, the authors are now trying to determine if this apparent relationship still holds true for bigger sample sizes. And they want to see if there are other simple characteristics that underlie other complexities seen in galaxies. Part of that effort will involve the development of a new instrument at the Australian Astronomical Observatory to succeed SAMI. Called Hector, which is an incredibly tortured acronym involving the use of hectobundles, which are hexagonal optical fibre bundles with independent cores, it'll be capable of observing 100 galaxies at a time, allowing it to obtain integral field spectroscopy of 100,000 galaxies over some 3,000 square degrees of sky. You're listening to SpaceTime. I'm Stuart Gary. NASA has announced plans to send a helicopter to Mars in 2020. The small autonomous rotorcraft drone will travel with the agency's next Mars rover mission, slated for launch in July 2020. NASA's chief Jim Bridenstine says the idea of flying a helicopter in the skies of another planet for the very first time is incredibly thrilling. Mission managers hope the historic flight will inspire students all over the United States to become scientists and engineers, paving the way for even greater discoveries in the future. The Mars helicopter project's being developed at NASA's Jet Propulsion Laboratory in Pasadena, California. It's designed to demonstrate the viability and potential of heavier-than-air flying vehicles on the Red Planet. Started in August 2013 as a technology development project, the Mars helicopter has undergone 4 years of design, testing and redesign in order to get the autonomous rotorcraft's mass down to below 1.8 kilograms. Its fuselage is no bigger than a cricket or softball, and its twin counter-rotating blades will bite through the thin Martian atmosphere at almost 3,000 RPM. That's some 10 times the rate of helicopters on Earth. Thomas Sabuchin, the Associate Administrator for NASA's Science Mission Directorate, compared the Mars helicopter to the Wright brothers' first controlled-powered flight on Earth 117 years ago. The Mars helicopter contains special built-in capabilities needed for operation on the Red Planet. These include solar cells to charge the lithium-ion batteries and a heating mechanism to keep its electronics warm through those cold Martian nights. By the way, the altitude record for a chopper flight on Earth is about 12,200 metres. That's 40,000 feet. The thing is, the atmosphere on Mars is only about 1% that of Earth's. So, when the Mars helicopter is on the Red Planet's surface, it's already at the Earth equivalent of 30,500 metres or 100,000 feet. To make it fly at that low atmospheric density, NASA's had to make sure it's as light as possible, while still being as strong and powerful as it can be. And of course, before you can fly a helicopter on Mars, you actually need to get it there first. And so the Mars helicopter will be attached to the belly pan of the Mars 2020 rover. Once the Mars 2020 rover is on the Red Planet's surface, a suitable location will be found to deploy the helicopter down from the vehicle and place it on the ground. The rover will then be driven away from the helicopter to a safe distance from where it'll relay commands from Earth. Once the helicopter's batteries are fully charged and a myriad of pre-flight tests performed, mission managers at JPL will command the Mars helicopter to undertake history's first ever autonomous flight from the surface of another world. Because there's no pilot with it on Mars and Earth several light minutes away, the Mars helicopter can't be flown by joystick from Earth in real time, as you would do with a conventional drone. Instead, the Mars helicopter has an autonomous capability that will enable it to receive and interpret commands from the ground and then fly the mission on its own. The full 30-day flight test campaign will include up to 5 flights of incrementally further flight distances, up to a few hundred metres, and time durations as long as 90 seconds. On its first flight, the Mars helicopter will only make a short vertical climb, no more than about 3 metres or so. It'll then hover for about 30 seconds before landing again. As a technology demonstrator, the Mars helicopter is considered a high-risk, high-reward project, and so it's been designed so that the Mars 2020 primary mission won't be impacted if the chopper doesn't work. On the other hand, if it does work, you can imagine extraterrestrial choppers having a real future as low-flying scouts and aerial vehicles used to access locations not reachable by ground transport. The ability to see what lies beyond the next hill has always been crucial for exploration. NASA already gets great views of the Martian landscape from the surface as well as orbit, and with the added dimension of a bird's eye view from a Mars chopper, you can only imagine what future missions will achieve. NASA's Mars 2020 will fly on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Base in Florida on a 6-month flight plan expected to reach the Red Planet in February 2021. Once on the surface, the rover will conduct geological assessments of the landing site, determine the habitability of the environment, search for signs of ancient Martian life, and assess natural resources and hazards for future human explorers. Scientists will also use the instruments aboard the rover to identify and collect samples of rock and soil, and then seal them in special containers for retrieval by a future joint sample return mission with the European Space Agency slated for the early 2020s. You're listening to SpaceTime. I'm Stuart Gary. Scientists have discovered a new type of turbulent magnetic reconnection, which is dissipating energy beyond Earth's protective magnetic field. The findings, reported in the journal Nature, help explain how turbulent magnetic fields dissipate energy throughout the universe. Magnetic reconnection occurs when two opposing magnetic field lines snap, explosively flinging away nearby particles at high speeds. They then reconnect with each other, in the process dissipating massive amounts of energy. Earth's magnetic field shields the planet, helping protect it from cosmic rays and the relentless onslaught of protons, electrons and other charged particles streaming from the sun in the solar wind. However, magnetic reconnection involving electrons and ions has been shown to affect the magnetosphere's protective ability. In fact, magnetic reconnection is one of the most important processes in the space contributing to dynamic space weather systems, which scientists want to better understand. The thing is, the process has always been observed in the magnetosphere under relatively calm conditions. But just outside Earth's magnetic field, the solar wind's onslaught of electrons and ionized gases creates a turbulent maelstrom of magnetic energy known as the magnetosheath. And scientists want to know if magnetic reconnection also occurs in this magnetosheath zone, and if so, how that affects the planet. To find out, NASA developed the Magnetospheric Multiscale mission, or MMS, a constellation of 4 spacecraft orbiting the Earth in a pyramid formation, gathering data every 30 milliseconds. These highly precise measurements allowed researchers to observe a never-before-seen turbulent electron-only form of magnetic reconnection in the magnetosheath. In fact, the findings provide the first evidence of magnetic reconnection occurring at very small spatial scales. One of the study's authors, Professor James Drake from the University of Maryland, says the findings help explain how magnetic energy in churning turbulent systems cascades to smaller and smaller scales before finally being fully dissipated. Magnetic reconnection occurring at electron scales with no ions involved explains how that happens. The new observations also show that while normal magnetic reconnection occurs when two magnetic fields pointing in opposite directions annihilate each other, in this case a large ambient magnetic field survived after annihilation occurred. Electron-scale magnetic reconnection may also help explain why the solar corona, an expansive layer of charged particles surrounding the Sun, can reach temperatures of millions of degrees compared to the 6,000 degree temperature of the Sun's visible surface. After all, it's supposed to get cooler the further away you move from a heat source, not hotter. Because turbulent reconnection involves only electrons, it's remained hidden from scientists looking for ion jets, the telltale signature of standard magnetic reconnection. Compared with standard reconnection, in which broad jets of ions stream out tens of thousands of kilometres from the site of reconnection, this turbulent reconnection ejects narrow jets of electrons only a couple of kilometres wide. I'm Stuart Gary. This is SpaceTime. A new study claims Earth's orbit is being elongated every 405,000 years by the gravitational perturbations of the planets Venus and Jupiter. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, suggest that these orbital changes have influenced the Earth's climate and the evolution of life on Earth for at least the past 215 million years. The study's lead author, Professor Dennis Kent from Rutgers University in New Brunswick, says this long cycle was predicted from observations of planetary motions going back some 50 million years. The data shows that for the last 215 million years, gravitational tugs from Jupiter and Venus have slightly elongated Earth's orbit every 405,000 years. It means scientists can now very precisely date changes in the climate, environment, the rise of the dinosaurs, the rise of mammals, and the fossil record generally around the Earth to this 405,000-year cycle. It means scientists can link climate cycles to reversals in the polarity of Earth's magnetic field. That's when compass needles point south instead of north, and vice versa. And to sediments both with and without zircons, minerals with uranium in them that allow radioactive dating. The authors found the climate cycles are directly related to how the Earth orbits the Sun, and slight variations in sunlight reaching Earth which lead to climate and ecological changes. During this 405,000-year cycle, Earth's orbit changes from close to a perfect circle to about 5% elongated, especially every 405,000 years. The scientists studied the long-term record of reversals in the Earth's magnetic field in sediments in the Newark Basin, a prehistoric lake that once spanned most of New Jersey, as well as sediments with volcanic detritus in the Petrified Forest National Park of Arizona. They collected drill core samples from rock from the Triassic period, some 202 million to 253 million years ago. It confirmed that this 405,000-year cycle is the most regular astronomical pattern linked to Earth's annual trek around the Sun. Prior to this study, dates to accurately time when magnetic field reversals occurred were unavailable for about 30 million years of the late Triassic. And that's important because that's when dinosaurs and mammals appeared and the Pangaea supercontinent broke apart. And of course it was that breakup which led to the formation of the Atlantic Ocean, with massive seafloor spreading as the continents drifted apart, and a mass extinction event that affected dinosaurs at the end of that period. You're listening to Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. The after effects of the 9/11 terrorist attacks in the United States continue to take their toll, with a new study finding that New York City firefighters exposed to the 9/11 World Trade Center disaster site face an increased risk of developing myeloma precursor disease, which can lead to the deadly blood cancer multiple myeloma. The findings, reported in the Journal of the American Medical Association Oncology, follow on from earlier studies in the Lancet Medical Journal, linking first responders to the Al-Qaeda terrorist attacks to increased cancer rates caused by the toxic chemicals released in the deadly strikes. The aerosolized dust from the collapsed Twin Towers exposed firefighters and other first responders to unprecedented levels of polychlorinated biphenyls, polycyclic aromatic hydrocarbons, dioxins, asbestos, and other potential carcinogens, as well as diesel fumes from the heavy machinery used in the 10-month rescue and recovery effort. Most multiple myeloma cases are diagnosed in people older than 65, with only 5% of cases occurring in people aged under 50. Only half of those diagnosed with multiple myeloma are still alive 5 years later. The series of 4 coordinated attacks by Al-Qaeda terrorists on the United States on the morning of Tuesday, September the 11th, 2001, killed some 3,000 people and injured over 6,000 others as Muslim extremists hijacked 4 commercial airliners, flying 1 into the Pentagon in Washington, D.C., and 2 into the Twin Towers of the World Trade Center in New York City. The fourth hijacked airliner, which was targeting the White House, was brought down in a field in Pennsylvania after the doomed passengers bravely fought back against the terrorists. A new study has found that thousands of the most popular apps and games available mostly free of charge in the Google Play Store may be violating the United States Children's Online Privacy Protection Act by potentially illegally tracking children's use habits. The study by scientists at the University of California, Berkeley and the IMDEA Networks Institute in Madrid analyzed 5,855 apps for kids, finding that 57% may be collecting and sharing the personal data of children aged under 13 without parental consent. Researchers found that 28% of these apps accessed confidential data protected by Android permissions, and that 73% of apps transmitted confidential data over the Internet. Among the apps analysed, 4.8% presented clear violations when apps share location or contact information without consent. 40% shared personal information without applying reasonable security measures. 18% shared persistent identifiers such as mobile phone numbers with services or business partners for prohibited purposes such as ad targeting. And 39% didn't bother taking sufficient measures to protect the privacy of children. Each of the apps studied was installed on average more than 750,000 times, which means they may be potentially in use on millions of devices on a global scale. A new study suggests that a giant extinct species of bird may be responsible for around 1,000 mysterious gravel mounds in the Australian outback. The strange mounds are pretty well circular, about 40 metres in diameter and over 2 metres in height. Scientists estimate they could be over 20,000 years old. The findings, reported in the Australian Journal of Earth Sciences, suggest the most likely culprit was a bird that builds nesting mounds, similar to the modern-day malleefowl, only much, much bigger. Well, it's not quite Mr. Red, but a new study has shown that horses can read and then remember people's emotional expressions, enabling them to use this information to identify people who could pose a potential threat. The findings, reported in the journal Current Biology, used controlled experiments in which domestic horses were presented with a photograph of an angry or happy human face, and several hours later saw the actual person who had exhibited the expression, but now in an emotionally neutral state. This short-term exposure to the photograph of a person's facial expression was enough to generate clear differences in subsequent responses upon meeting the individual later the same day. The study found that despite humans being in a neutral state during the meeting, a horse's gaze direction revealed that they perceived a person more negatively if they had previously seen that person looking angry in the photograph rather than happy. The findings are all based on previous research which found that animals tend to view negative events with their left eye. That's due to the right brain hemisphere specialization for processing threatening stimuli. You see, information from the left eye is processed by the right brain hemisphere. Interestingly, the differences in reaction only applied to persons the horses had actually seen in the photograph. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.